So there it is. The result of that render where we can see all the kind of glass fracturing here. I mean, it's not the highest resolution image in the world, but nonetheless, you can see that this is not just a flat pane of glass. We're seeing all the fractured pieces. And again, that's because we're looking through the window to see the seams that would normally be hidden by the fact that these other areas are opaque. So fortunately, fixing that isn't as hard as you think it would be, because Houdini fortunately comes with some tools now that will make it easy for us. You know, like the rest of the RBD fracturing tool set, it makes these convenience nodes that do these kind of address these common issues that come up. And as you can imagine, broken glass comes up quite a bit in visual effects. So let's use a split to isolate the glass. So I'm going to go here, and I'm going to use, remember those part attributes we've been using? I'm going to say part type equals glass, points, and there you go. So now the left input, or rather output, is what I asked for. It's going to isolate this. And then the other output is going to be everything else, which is the concrete and whatnot. So we need to unpack this because we need to deal with the polygons. And then we need to do an RBD connected faces. This is node 1 in the 2-node toolkit used for solving this problem. So RBD connected faces says store in these two attributes, opposite face ID and primdist, for every primitive, what is the closest primitive to me? So when we're dealing with these, I guess it's not doing a great job. Let me do well, in any case, if we look at any individual piece, it has these seams on one side, and then the piece next to it has the matching polygons on the other. So although we see one square here, there's really two. One that belongs to this piece, and one that belongs to the neighboring piece. They just happen to be right on top of each other. And that's what this is going to detect. It's going to detect the other ID of the other one and how far away it is. Now we don't want to do this on every frame. Right now, this is, you know, an animated thing. We can see that because, well, we know it is because it's coming from the sim. And we can see this little clock. So let's make a time shift that says only do this in the first frame. So now, on any frame, it's only asking for the first frame. So it's no longer animated, and you can see the clock disappeared. So now we'll only do this calculation on the first frame when the glass was together. So all we need to do is say, on the animated frames, on the unpack stream continuing here, we can copy those attributes back over, the ones that we determined on the first frame. So again, that was opposite face ID and primdist. So I'll just copy those over, opposite face ID and primdist. So now this animated one has it, the calculation that was done in that one frame, and we can finish with an RBD disconnected faces, which is the matching tool. And so what to do? Delete the connected faces rather. So if we look in here, they're gone now. Sorry. So if I turned it on, there they are. Turn it off, they're gone. What's interesting though is that on other frames later on, they'll be back because now they will have exceeded their original distance. It'll keep looking on every frame. Where is my old friend? Where is the opposite face ID and how far is he now? Is he greater than this distance away from me now? Well then stop deleting it essentially. Let them be visible again. So now we once again have the sides of our glass again. But this is a really cool way, so again, see how they're all here? But if we keep going back, you'll see them disappear the closer they get, and there we go. And then it's back to being one continuous sheet of glass. I can actually see there's a few primitives in there for some reason, or at least it appears that there are. But that's the way it goes. So this is cool because even when things are moving together, sometimes they're not actually broken yet. So these pieces moved. It's not just detecting movement. If the pieces move together, but they're still glued together in the sim, well, they shouldn't be broken yet either. So these ones are broken, but these ones are not. So very cool. Good work there. So that's it. That's the end of the glass. So I'm just going to put a special null here for glass, and then a reminding null over here for concrete. We're still going to render them both together, at least in Mantra. So we'll merge them back together again. Like so. So now we have a mixture of some packed things. You know, all the concrete stuff's still going to be packed, but the glass is going to be actually regular polygons now. But that's okay. Mantra can handle that just fine. So this will be our new thing that we should be rendering. So go back over here, set our render building to point to that instead. Once it decides to do it. There you go. Okay, so now let's go back to the first frame and re-render that first frame. And we should see the spider webbing go away on here. So let's see what we get. And as we can see, it has. You can see how these are just flat pieces of glass now. That's what they looked like before, already fractured. Now they're good. Sweet. So I'm gonna actually go ahead and remove that from our little collection of things. I want to get back to frame 96. There's one more thing I would like to do before we finish up our rendering stuff here. And that's going to be comparing this look, which is pretty good, with the idea of increasing the number of diffuse balances on here. This is just purely something that's going to make your render look a little bit better, but at a great render expense. So, you know, if you feel like your renders are taking too long as it is, by no means do you need to turn this on. But this will say, don't just light everything based on the lights. Do a bounce, if you will, also known as global illumination or really gathering. But in any case, you're going to see that everything's going to get a little bit brighter because some of the light that reflects off the ground is going to reach our pieces. It's a subtle effect that, again, is relatively expensive, but it's quite nice. So you can already see it's taking longer to render, it's taking longer to resolve these things. But nonetheless, just look at the flat side of these faces here, and you can see a pretty big difference. In fact, get out of here, Duolingo. I wonder if those show up in the lessons. Anyway, what's really nice about it is when I had it looking like this, you know, these two things, I mean, it looks pretty good. I mean, I have shadowing and all that jazz. But now with this, the light mixes together and it feels more integrated. They're both sitting kind of in the same environment more than here. So again, you can see how much bluer, how much lighter bluer all these things are because this light blue from our very bright light that we increased to intensity 5 is now shining. It's bouncing off that and splashing onto this, which is something that happens in the real world. And that's it. We've done everything. Now I get to do my favorite part of every lesson, which is doing this. And then I get to put this into the lesson preview. Boop, 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 boop. Cool. With that done, we can actually stop this render and start the actual render. As you can imagine, especially with the diffuse limit to 1, this will take a while. But it's 10:30 at night where I am, so I'm just going to let this render overnight, and hopefully we got something in the morning. So there it is.